Okay, for what we have regarding the determination of domain and asymptotes of a rational expression, here we have r of x is equal to x cubed minus 4x all over x cubed minus 6x squared plus 8x. Now again, for the domain, okay, the denominator cannot be 0 in value. Okay, so we have with the denominator, we have the x cubed minus 6x squared plus 8x cannot be at 0. And if we look at factoring, okay, so we have x times the quantity of x squared minus 6x plus 8 cannot be 0. And the trinomial can be factored. So we have x times the quantity of x minus 2 times the quantity of x minus 4 cannot be equal to 0. And for what we have in this particular case, now we have with our factors of x, now we have that x cannot be 0. X minus 2 cannot be equal to 0, so we have that x cannot be at positive 2. And we have with x minus 4, okay, this also cannot be 0, so we have the x cannot be equal to 4. So we have for the domain, okay, and we have displaying what we have in interval notation. All right, so we have with the zeros, they have 0, 2, and 4. Now for the lowest values, they have those values x that will be less than 0. And then we have for the next group, we have those values of x that will be greater than 0 and less than 2. And then we have followed by those values of x greater than 2 and less than 4. And we have for the rest of the set, we have those values of x that will be greater than 4. So that is going to make up the domain. Okay, now there is a potential for there to be up to 3 vertical asymptotes. Now if we look at just what the vertical asymptotes are, they're going to be the exclusions from the domain whose factors will still be around. Okay, once r of x is displayed in simplest form. Okay, now we have for factoring. Okay, now we have with x cubed minus 4x. Now we have a common factor with x, and we have times, okay, the quantity of x squared minus 4, and this can be factored even further. Now we have x cubed minus 6x squared plus 8x, and again, if I go ahead and completely factor, okay, so we have x minus 2, and x minus 4. And looking at simplifying, okay, but first we have with factoring x squared minus 4 from the numerator, I have x plus 2 and x minus 2. Again, we have with the denominator, so I have x minus 2 and x minus 4. And what's going to happen here, okay, we're going to have x to cancel out. And also we're going to have x minus 2 is going to go out. And so we have with the simplified form, okay, we have x plus 2 all over x minus 4. All right. And because we have cancellations, we have x equals 0 and x equals 2. In other words, the zeros from the factors that canceled out, okay, those will be holes in the graph. Okay. And since we have x minus 4 to stick around, okay, x minus 4 remains. So that means that with this factor remaining, okay, there's going to be a vertical asymptote. And the vertical asymptote we're going to have at x is equal to 4. Now, in terms of any other asymptotes that we have, and if we go back to the original function, okay, so we have r of x, and again we have equal to x cubed minus 4x. And and we have all over x cubed minus 6x squared plus 8x. Now for what we have in the numerator and denominator. Okay. All right, so this will come down to degree comparisons. Okay, so you have n is equal to 3, and we have the m is equal to 3. Now the degrees are going to be the same. Okay, so we have that n is equal to m, and for what this is going to signal is that there will be a horizontal asymptote, and this will be a constant that will come from taking the ratio of the highest order terms. So we have for the horizontal asymptote, okay, so you have y is equal to x cubed over x cubed is equal to 1.